Let me get the recording going, and we are recording, and I will turn it over to you.
All right. Good morning, or afternoon, I guess, for you guys. My name's Anna McCullough. I am a building performance engineer located in Denver, Colorado. I was originally an HVAC designer, so definitely will focus a little bit on the HVAC stuff, but we'll talk through all of the performance requirements for the code. I work for a small sustainability firm located in Denver. We are Group 14 Engineering. We are building performance engineers, commissioning agents, and then also sustainability consultants. So I'm just going to hop right into it. So first, I'm going to go through the prescriptive path requirement so that we can understand how the performance path actually differs from the prescriptive path. Very quick overview of the prescriptive path, delve into the performance path, and then we'll talk through some of the key differences between IECC and ASHRAE. And then the top 5 efficiency strategies affecting whole building performance. And this is definitely looking at it from a climate 5 perspective, but we, a lot of them will transfer over to your all's climate as well, like lighting, things like that. I also wanted to note that this is all for the 2015 IECC. I have a couple notes in here for how the 2018 IECC changes, but the majority of everything we're going to be talking about is the 2015 IECC, or ASHRAE 90.1 2013. It's friendly cousin. So as you all know, the prescriptive method, you have 3 things you have to meet within the code. All the mandatory requirements listed in the IECC, the prescribed criteria, and then 1 additional energy efficiency package located in section C406. When we look at the trade-off approach, you're talking about CommCheck, you still have to meet all those mandatory requirements. Now you can trade off some of the insulation or glazing values within your envelope, that UA calculation. And then also we have lighting trade-offs from space to space. If you were complying just prescriptively, you could not do the lighting trade-offs. You also have to comply with that 1 additional energy efficiency package. The UA alternative, just to kind of set the scene for this, I want to help you guys understand, if you don't already, that there is some trade-offs happening within CommCheck that's allowing you to say, I want to put R8 continuous insulation on the north wall, but my firewall requirements are not allowing me to put R8. I need to have R7 on my south wall just because there's another building so close, whatever. So you can do some of that trade-off within CommCheck. And then, as we talked about, the trade-offs between the spaces of the lighting. So that's just within CommCheck. And then those energy efficiency packages, we have the more efficient HVAC performance, on-site renewable energy, reduced lighting power density, the dedicated outdoor air system option, enhanced lighting controls, or high efficiency service water heating. And why it's important to understand this is that when you look at performance modeling, and we'll get into this a little bit more, you have to see a 15% cost savings from your baseline to your proposed. And so what that 15% is trying to make up is for this additional energy efficiency package that the team does not have to select when they go, when they comply with the code via the performance method. So then when we look at the 2015 to 2018 IECC, there's not major changes. They really reorganized the code for the 2018 IECC. They added some mandatory control requirements, especially in hotel rooms for HVAC. Lighting mandatory control requirements, reduced lighting power density slightly. They added 2 additional energy efficiency package options, enhanced envelope and reduced air infiltration. The reduced air infiltration is going to be tough to meet. And then they added an appendix for solar ready. Okay, so let's get into the performance method. So like we talked about, you still have to meet those mandatory requirements that are listed in the code. Every section that says mandatory next to it, they still have to show compliance with. And I'll give you an example report of what we supply to show you guys where we list all of our mandatory requirements. We show where they are in the drawings or specifications, so they're easier for the code officials to find. And then you also have to meet that 15% energy savings to show that you are providing that level of energy efficiency that the building otherwise would have to meet if they were complying with one of those additional energy efficiency packages. Okay, so the building performance method is section C407 within the code. And then I also have listed here all of the mandatory sections within the code. So they still have to show compliance with all of those mandatory requirements. And I will repeat that many, many times. The prescriptive requirements do not have to be met. They do not have to supply in climate zone 5, we have R13 continuous insulation plus R7.5, or sorry, R13 in the studs, R7.5 continuous insulation. They do not have to meet that requirement. They can have just R7.5 continuous. Or we have a lot of project teams say, we don't want to do continuous insulation. We only want to put insulation in our studs. And so we can find ways to offset some of that increased heating and cooling energy use for the lesser insulation by reducing lighting power density or having a more efficient HVAC system. So other requirements, the whole building annual hourly energy model must be provided. So you can't just be doing a calculation. It has to be an hourly energy model. The proposed design compared to the standard reference design, all of the inputs into your energy model are listed. And then C407 has requirements for your proposed model, how to model the baseline model in comparison. We'll get into some of those as we keep this moving. And then like we talked about, 15% less annual energy cost, and the permit submittal must include a detailed energy modeling report. So here's an example. Within the city of Denver, they require our energy model report to be located on a sheet. And that is because they want to be able to find it quickly. They don't want it to get lost in the building department. So here's an example of what we provide. On the top left there is our results showing cost savings, that little table. Highlighted within red is our table showing the mandatory provisions. So we have it broken out by line item. If it is a mandatory provision, it's listed here. We have our sheet or specification location, and then also a column for you guys to check things off if you would like to. Within the blue box is the baseline and proposed envelope lighting, HVAC, and service hot water energy model inputs, and then where we found those inputs within the sheets or within the construction documents. So if we have a different glazing on the southeast and west facades than we do on the north facade, it's located, that is all listed here, and we tell you where it's found within the drawings or specifications. That green box is a commissioning letter that the city of Denver requires us to provide. We have a little depiction of what the energy model looks like. We have our inputs showing what the utility rates are that we used. We'll get into what's allowed there in a minute. We have our weather file information listed there. And then within the yellow box, which is the model outputs, this is everything that comes out of our well, not everything. You guys don't want to see everything. It's about probably 150 pages long, a very condensed version of what comes out of our energy model. So we're showing energy use by end use. We're showing energy use by natural gas or electricity, unmet hours, and then utility costs also are listed here. So you can make sure that they match what's listed in our first table showing the energy cost savings. Does it match what's coming out of the energy model? So there's a couple checks that you guys can do within there. What's really nice about this, and it's something we've really worked with the building department to come up with, this letter allows you guys to say, all right, they're taking credit for increased insulation. It's located on this sheet. And you guys can find it quickly so that you're not trying to figure out where we found our information. It's faster for you guys to cross-check. So within the building performance, what we often find is, like I said, we trade off envelope with lighting and HVAC. This is an example of a office building in Denver that has a 70% window to wall ratio. The only way to provide 70% window to wall ratio is to comply with the code via the performance method. In our experience, if you are at a 2015 IECC, you cannot provide enough insulation in your walls to offset that UA calculation within CommCheck. We have a lot of buildings remove continuous insulation on the exterior walls, and it just really allows design teams more flexibility. So if they want to provide, I had a project that wanted to do a glass ceiling over top of their pool in their natatorium because they thought it would be really cool. And the only way to do that was to comply with the code via the performance method. And again, all those mandatory measures must still be met. So if it is a required mandatory measure, they have to show that they are complying with it. Utility rates. So this is a list of compliance requirements that are listed in section C407 of the 2015 IECC. Utility rates can be from the Department of Energy, the EIA's website, or local utility rates. Off-site renewable energy shall be treated and priced the same as purchased energy. So that's removed, you remove that energy from both the baseline and proposed models. So if your building is buying into a solar garden offsite, which is something that buildings in Denver are looking at, which is why I have it listed here, but they cannot remove that energy from their proposed model without also removing it from their baseline model. On-site renewable energy shall be omitted from the annual energy cost of the proposed design. And then unmet load hours for the reference design, which is your proposed design, or I'm sorry, it's your baseline design, must not be less than those of the proposed design. And the reason for that is that they really want to make sure that you are not oversizing your systems within your baseline to increase your baseline's energy use so much that you're getting increased energy savings within your proposed. So if you have 5 more unmet hours in the proposed than the baseline, that's not something that the energy modeler is trying to get away with. But if you have 400 more unmet hours in the proposed than the baseline, that's something that should be noted, right? And that's why you want to see those energy model outputs. So the standard reference design of the envelope. So this is your baseline energy model, and all of these inputs should be listed in that report that I gave you an example of. Your baseline envelope meets the code prescribed insulation levels. There's mass wall where the wall is mass, otherwise it's steel framed wall. You don't have a metal building in your baseline design. Even if you have a metal building in your proposed, you have steel framed wall in your baseline. You have to meet the code prescribed glazing area and insulating factors. So if you have 70% window to wall ratio in your proposed, you can only have 40% window to wall ratio in your baseline. If you have 30% window to wall ratio in your proposed, you have 30% in your baseline. You do not get credit for reduced glazing area below that 40% window to wall ratio that's prescribed. Skylights, same thing, maximum 3% of your gross roof assembly. Another note here is that within your baseline, you should also be seeing those different solar heat gain coefficients within on the southeast and west facades from the north facade. So you want to make sure that they're actually modeling that reduced solar heat gain coefficient glazing on the southeast and west facades. Another note, if you have shading, so permanent shading only, not operable or blinds. So if you have permanent shading in your proposed design, you do not model that shading in your baseline. And we'll leave time for questions at the end here for sure. It's a pretty quick presentation. This is an example of a multifamily building located in Denver that has a 65% window to wall ratio, and that's on the right side, so that's our proposed design. On the left side is the baseline design, and that has only that 40% window to wall ratio. So you can see that we took a big hit for that increased glazing. You can actually see the difference, how much glazing was modeled in both buildings. Sorry, I just want to go back real quick. So within this building, to offset this increased glazing, we had high efficiency all LED fixtures located everywhere. We had a very costly HVAC system that was very high efficiency, but these were high-end units. They wanted that floor to ceiling glazing in all of these units, and that's why, so they had to increase the efficiency of all of their other systems to really offset that increased glazing. So more standard reference design notes here. The lighting power densities within your baseline are going to be modeled per section C405.4.2. So that's where all of your space by space or building area method lighting power densities are. You cannot take credit for multifamily lighting in the performance method because it is not listed as a space type in the lighting power densities in section C405.4.2. So you have to model those lighting power densities between the baseline and proposed the same for the performance method in multifamily, sorry. You have to model daylighting in your baseline design. So what we don't want to see is project teams taking credit for daylighting controls that are required by code anyway. So you model it the same in the baseline and proposed unless you have increased daylighting control above what is required by code. So if they extend the depth of the daylighting zone within the proposed design, then you model that accordingly in the proposed design. Exterior lighting powers, you model the allowed exterior lighting power density in the baseline. You want to make sure that the lighting controls are modeled as required. Again, what we don't want to see is people modeling the exterior lights as continuously on in the baseline, so you get a ton of savings. They have to be on either a timer or a photosensor. And then interior gains are the same between the baseline and proposed model. And this is a good note as well. A lot of times within multifamily projects, we see clients installing Energy Star appliances, which is really great and is a great energy savings measure, but they can't take credit for that within the building performance method for code compliance. So it's just something to note that they should be listed. Your interior gains should be listed as 1.7 watts per square foot or whatever it is, and it should be the same between the baseline and proposed unless you guys allow something else within your jurisdiction. So here's the HVAC table. The section C407 tells you how to figure out what HVAC system should be modeled in the baseline. So you start on your condenser source. So we'll do an example. I heard that you guys have a lot of multifamily. So we'll do an example of PTHPs within, or sorry, heat pumps, split heat pumps in the proposed design. What should your baseline be? Your condenser cooling source is being cooled by air. So we have, we're in that bottom section of the chart now. And then your heating system classification is a heat pump. So now you have, you're a single zone residential system, you are system 8. So if we go to here, the next chart, system 8 is a package terminal heat pump. Fan control, constant volume, direct expansion coil, and electric heat pump. If we're looking, I'm going to give another example. If we're looking at a air-cooled chiller for an office that serves 4 pipe air handling units with hot water reheat. It's a typical system that we see a lot in Denver. I'm sure you guys probably see the electric reheat, but so our condenser, our air-cooled chiller is still being cooled by air. So we're still down here. And then we have that fossil fuel hot water heat. And we are not a single zone residential system. We're not a single zone non-residential system. We're a VAV system. So we're system 4. System 4 is a packaged variable air volume with reheat. So it's a VAV fan, DX cooling, and hot water fossil fuel boiler. So you'll see with an air-cooled chiller, you're going to get a lot of savings if you select a highly efficient air-cooled chiller. Your baseline system is going to be a DX coil. Now, if we had a water-cooled chiller, again, we're up in this chart now. And so we're looking at system 2. System 2 is VAV, chilled water, and hot water fossil fuel boilers. So you guys are, now we're comparing a chilled water coil or a water-cooled chiller to a water-cooled chiller. You're going to see less savings there. The other note, we see a lot of project teams that like to consider water source heat pumps for multifamily because they're great pieces, well, can be great pieces of equipment. There's some good efficiency within those water source heat pumps. And we have a lot of clients that really like to use them in their buildings. But what's important to note here, if you have a water source heat pump in your proposed design, you have a water source heat pump in your baseline design. And it's a lot harder to get those annual energy cost savings when you're comparing an apples to apples system. So a water source heat pump in the baseline to a water source heat pump in the proposed. So something to keep in mind there, double check and make sure that they are selecting the correct HVAC system within the baseline model. There's all these notes below this table that tell you exactly how to model each system, and it's almost a full page of notes. For example, within a VAV system, they say to allow your VAV boxes to turn down to 0.4 CFM per square foot in your baseline design. So that's increased energy over your design, which is probably a 30% turn down. So there's some things like that that are going to differ between the baseline and proposed just by the nature of those notes. So the mechanical controls in your standard reference design or your baseline should meet the mandatory and prescriptive requirements within the code. So a good example here is if we have a proposed system with VRF and DOAS, they are not providing an outdoor air economizer. And the standard reference design for that same system, we can run through it if you guys want to, but it's VAV with parallel fan-powered boxes and electric reheat. That system has an airside economizer. And so you want to make sure that it's listed that they are modeling the airside economizer in the baseline design and not in the proposed design, unless they designed it, which would be expensive. But yeah, unless they designed it that way, they're going to take a hit for not providing that airside economizer in the proposed design. Now, if they were complying with the code via ComCheck, they would have to provide that airside economizer because it's a prescriptive requirement in the mechanical controls mechanical section. Outdoor airflow always is modeled identically between the baseline and proposed. You have the same amount of outside air coming into your building in the baseline design and the proposed design, no matter what your HVAC system is. So now we're going to compare to the ASHRAE 90.1 2013. So they have mandatory requirements, prescribed criteria, and they do not have additional energy efficiency packages. We have seen quite a few multifamily projects start looking at complying with ASHRAE 90.1 2013 via their energy performance method, which I'll get into in a minute. So, and that's, we'll talk about it in a minute, but so there's mandatory requirements. They can still do the UA calculation and lighting trade-offs just like you can in IECC. But now within the energy cost budget method, which is their energy performance method, it's chapter 11 if you're really curious. It's almost identical to section C407, except for they only have to have $1 of energy savings as compared to the baseline design. And the reason for that is on our next slide. There are additional mandatory measures required within ASHRAE 90.1 2013 that are not required in the IECC. And so what the IECC said was, well, look at all of these additional energy efficiency requirements in ASHRAE. We're not going to require those, but we are going to require either an additional energy efficiency package, that's section C406, or the 15% cost savings in section C407. So within ASHRAE 90.1 2013, you have additional daylightings required, additional occupancy and vacancy controls on your lighting, automatic receptacle controls required, electrical energy monitoring, so sub-metering of end uses, and then utility metering, utility meter monitoring, say that 10 times fast, is also required. So you must record every 60 minutes and data reported hourly, daily, monthly, and annually. So because of all of these additional energy efficiency requirements within ASHRAE, they said you only need $1 of energy cost savings compared to the baseline. If you guys are really familiar with ASHRAE, and I'm not sure if you are or not, but for those of you who are, section 11 is much different than Appendix G. Section 11, which is the energy cost budget method, has a completely different energy modeling method than Appendix G, which is what we model for LEED, for example. So it's a good note to make sure that they're not using Appendix G for their compliance. Appendix G is not a code compliance option. It is Chapter 11 or IECC Section C407. So I have the mandatory sections for ASHRAE listed here. And it's the same requirements. The only difference is that this ASHRAE 90 is the $1 less than the annual energy cost. So, okay. And then, ooh, I flew through this really fast. Hopefully you guys have a lot of questions. The top 5 efficiency strategies, and again, this is Climate Zone 5B, so this is an example of the annual costs for a baseline building. I believe this is an office building. So we have a lot of HVAC energy use, fans, cooling, heating, a little bit of water heating, interior lighting, exterior lighting, equipments, those plug loads, that's what's modeled the same between the baseline and proposed, and then a little bit of pumps. So optimizing your glazing selection per facade and reducing glazing areas is what we have found to be one of the most important efficiency strategies. So when we look at a building that has that 70% window to wall ratio, we know right away that there's going to be a lot of additional energy efficiency within the lighting and HVAC that's required to really bring back down the building's annual energy costs. Lighting power density is all LED. We see that in all of our buildings anyway, but that's kind of the first step for reducing this 21% of interior lighting. Lighting controls are crucial as well, making sure that those all function and they are designed and optimized. And then HVAC system efficiencies, part load efficiencies are really important. We all know that HVAC equipment it's like 85% of the time on average, I believe, it's running at part load. So we want to make sure that all of your compressors have really high part load efficiencies. And then fan efficiencies. So if we take an office building, for example, and we have a VAV rooftop unit, we've seen a lot of projects look at providing a fan wall in lieu of a single supply fan. And that allows us to reduce the fan energy when those fans are operating at part load and the building isn't completely occupied. And that really can reduce this 14% energy use, 14% cost of your fans significantly. And then HVAC controls, we always look at supply temperatures and system setbacks, trying to keep the building from using energy when it's unoccupied. Those supply temperatures and system setbacks for the baseline are prescribed within section C407. So if we can get a little bit more annual energy cost savings off of from optimizing those for a building, then we will, because it's oftentimes zero cost if they already have the BAS energy efficiency measure. So sorry that was really, really fast, but here's my info.
And it's just it's so dense. I mean, that's every time I hear any kind of presentation on the performance path, it just makes me really thankful that all I was getting is comm checks as a building official, because it's like CommCheck takes all the error. I mean, you can't put in a lower ER than is allowed. I mean, CommCheck kind of keeps folks honest, and makes it so much easier for building officials. It's just the performance path. I mean, unless you have an energy modeler on staff, I just don't know how most plan review departments, especially in bigger cities, you probably do have a dedicated commercial plan reviewer that specializes in energy or something like that. But you go to a mid-sized jurisdiction that you don't have the expertise on staff to do that type of review of a performance submittal. How often, when you submit them, in your experience, how often do you get comments or corrections, or do they just accept it?
So for the city of Denver, for the city of Denver, we get comments a lot. For other jurisdictions, not as often. What we will see is a question about, hey, we found this type of glazing is listed in section 088,000 of the specifications, but another type is listed on the drawings. Which one is the right one? Questions like that. But we do, and sorry, I promise I don't have the virus. So what we do is And what might be helpful is if I pull up an example code compliance report, if you guys want to see what our inputs actually look like. I know you can't read them off of that.
Oh, that'd be super cool. We've got time.
Yeah.
And I'm curious on your commissioning, is that typically, my very first ever credits on a book, I was part of the panel that rewrote the G4 commissioning guideline. And recently ASHRAE's come out. Jerry Kettler is a commissioning guru. He sits on all the boards and ASHRAE and all that. And I was the token building official. Like, hey, if we can dumb this down enough that a building official can understand it was kind of the goal. So they brought me in to be the baseline dumbed down guy. But ASHRAE recently has a new commissioning guideline out, and it's got a bunch of pretty handy checklists and sample submittals and forms. Are you familiar with that?
Yes. Yep.
Okay. I was going to shoot it over to you. I've been sending it to commissioning folks left and right, and they're appreciative of it. It helps their submittals with the city. But what the question was, typically, do you see the requests for commissioning? Are you typically having that initiated by the code requirement, or typically the building owner, or who typically is requiring that in your experience?
So the code obviously requires that
right
commissioning.
But most jurisdictions in Texas just conveniently ignore the commissioning section of the code. I don't know if it's that way in Colorado.
No, so we have, Denver obviously requires a letter showing that you already have your commissioning agent on board before you go to permit, before they'll allow you to permit. And then when you have the performance method, this letter has to be stamped by the engineer, it has to be stamped by an engineer of record. And you'll see, can you see my Word file that I popped up?
Yeah, it's clear.
So here's a list this is just our template for our checklist, but this is all of the mandatory requirements that we pulled out of the 2015 IECC.
Nice.
And we have our location here, but commissioning plans as developed by section C408, and we show where it's located in the drawings. Normally it's in the specs, but somebody has to stamp this. And in our experience, we just don't have, I definitely wouldn't stamp something where I know it didn't actually exist.
Right.
So just knowing that this letter has to be stamped by a design professional, I think has also triggered that person, whoever's stamping it, or to say, hey, where's your commissioning plan? Do you guys have a commissioning agent on board? And those questions.
Right. Yeah, that's always a great tool to have as a code official when you're arguing with a developer or builder. Okay, why don't you just give me a stamp? Give me a stamp from the engineer, because y'all don't like stamping things just frivolously, for sure.
Mm-hmm.
Yeah, and I'll send the commissioning checklist. I just had a question about the commissioning checklist. I'll send those out to all the folks on the webinar. I'll send you some really handy commissioning checklists, and then I'll also send everyone on the webinar. I stole it from the city of San Antonio. There's some really good checklists for commercial submittals, so I'll send that to everyone. I recently had a product manufacturer email me, and that's pretty handy. I like that. So on y'all submittals, do you typically, I see your sheet location is different. Do you have like an energy summary section that is y'all's protocol, or is it just kind of, how do you go about summarizing the energy portions of the building?
Yeah, so this is where we show all of our inputs in the energy model.
Okay.
And then, so we have a list of all of the energy efficiency measures that are kind of what is providing some of the savings located here.
Oh, that's handy.
And then here's our table that shows the annual energy cost savings and then cost savings.
Cool. And I'm not all that familiar with the performance in ASHRAE. I know, it's 85%, the 15% savings on the performance straight out of the IECC. You said it's just $1 savings in ASHRAE. Is that correct?
Correct. Yep. This would just have to be $1.
Right on. And then We hate economizers in Texas. Luckily they fixed it in the 18. It was broken in the 15, in my opinion. You know, you could put in more efficient equipment out in West Texas where it's dry in lieu of an economizer. But in Houston, where it's super humid, you couldn't put in more efficient equipment in lieu of an economizer. And in Houston, you want to be bringing in outside air for about 15 minutes a year. So, I mean, that was just broken in the code, in my opinion. But they fixed it in the 18. And so for all you code officials on there, if you're in climate zone 2 and you're sitting there looking at your code book and you're like, oh, I can't let you put in more efficient equipment in lieu of an economizer because look, it's 2A or B, whichever it was. But anyway, they fixed that in the 18, just so everyone knows. So you can, in my opinion, you can allow a more efficient equipment in lieu of an economizer.
Mm-hmm. Yeah.
Now in Denver, it makes a lot of sense. You
Yeah.
don't bring in outside air a lot.
Yeah, we want to. I mean, as long as from about the beginning of May through the beginning of October, it's nice and cool out, and we don't need a whole ton of cooling unless it's August, but
Cool.
still not as bad as you guys.
Is there a particular software? Have you used more than one software set for this performance modeling and submittals, or do you have one you like, one you don't like?
Yeah, so the software we use is called Open Studio, and
Okay.
the reason we use it is that it is free and it is open source. So there's a whole community of energy modelers that share information and share different codes, different coding for different building components, so that it's not proprietary for anybody. There are other softwares that are proprietary and you have to pay to use them. I do not have as much experience with them just because they are not, we do a lot of work with DOE and they are not funded by DOE and not allowed. So Open Studio with the Energy Plus processor is what we use the most frequently. There's plenty of softwares out there, but that one's free to use and pretty easy. Well, yeah.
And another question came in. So utility rates can be from DOE, energy admin, or local. So in somewhere like Oklahoma, where they're 5.5 cents a kilowatt hour, I mean, when would it be more advantageous to use the local rate versus like the DOE rate or energy admin rate?
Yeah, so it kind of depends.
Okay.
We always look at all utility rates and double check to see which one is going to benefit the project the most, honestly. So we'll have a project that, if it is an all electric building located in Denver, we've seen a big push to go all electric, and it doesn't make a lot of sense for us to use the demand rates that we have locally. For energy savings, it might make more sense for us to look at the flat rate that's provided by the EIA. And so it just depends. We have a processor that pulls all of the information out of the energy model, and we can apply different rates to it. But here you'll see we have listed the commercial utility rate that we've used for this project, our location and climate data, and then this is all the information that comes out of the energy model. Okay. And we have located here the virtual rate, dollars per unit energy that's listed here, unmet hours, and then there's also total energy costs. And this is what you want to be reviewing for to make sure that what they have listed above to show percent savings matches what's coming out of the energy model.
Right on. So if for the folks on the webinar, if you just Googled Open Studio energy modeling software, it would just come right up.
Yep, absolutely.
Okay, so there's no reason for me to send a link or anything. Okay, just got a couple more questions coming in. Let's see. Have you ever modeled any dynamic glazing?
Yes. What do you want to know?
I'd just be curious, what kind of difference did it have you? I guess was it worth it? I'm assuming it's still pretty pricey. Just your experience with it.
So in Denver, It's going to be a completely different experience than for you guys. We actually looked at it for the airport out here. They were building a new addition to their office building, and they were looking at it. They wanted to reduce cooling costs, but then they also wanted to reduce glare. Yeah, so we looked at it from two different ways. And from a cost perspective, it did not pay back. It was like a 45-year payback,
Okay.
I want to say. So what we do is we say there's a way to model the actual visible transmittance of the glazing depending on the solar irradiation hitting that panel of glass. And the energy model will calculate all of that for you. And so what was really interesting was that the glare reduction was so much. I mean, it was amazing how much the glare the glare reduction was, so that the airport was really considering it, even though there was a 45-year payback, just for the comfort of their occupants. You guys, it might make a lot more sense. But
makes sense. I can see that.
In Denver, it was definitely not going to pay back. And they had a great water-cooled chiller. I mean, there were a lot of other factors for their cooling was just so efficient that it just didn't pay back for them, but it would make their occupants a lot more comfortable.
Right on. Let's see, a couple more came in. If the project is going to have, basically the question alludes to trees on the project, do those count as permanent shading? And is it what baseline or standard reference, or how do you model trees, if at all?
Trees are not included because they do not provide shading in the winter, obviously. Well, at least here, they would drop all their leaves. I feel like you guys lose leaves in the winter too.
Cedar trees don't. I mean, could you make an argument for an evergreen tree, but it's just not allowed?
It's just not allowed.
Okay.
It's any sort of shades or fins on your building would be allowed to be modeled.
Okay.
Only in the proposed.
And then I've just had one more question. Oh, no, two more. Just had another one come in. So baseline system on proposed versus standard reference. Does the performance software know, or does the modeler have to know? I think that was alluding to the fact on like whether it's air cooled or water cooled, and you've got do you need to be able to go and look at the footnotes and input that correctly, or does the Open Studio know what has to be inputted
We
there?
have to go in and input it.
So you need to know.
Mm-hmm.
It sure would be nice, you know how CommCheck is idiot proof. It would be nice if we had a performance software that was idiot proof.
It would be, but there's just so many different permutations of combinations that you can have in a proposed design that will affect your baseline design, that there's really no good way to have it be idiot proof. I mean, it takes us probably about 2 weeks to get a baseline and proposed energy model up. It's definitely not a quick 15-minute process by any means. There's a lot of different inputs and analysis. And we always say that you can make an energy model do whatever you want if you know how to do it. So you just have to really take a look at what those inputs are listed in the report and make sure that they have all of that listed. But
Okay.
I can show you too. Maybe. Here we go. Just like for the HVAC system here, here's all our inputs. What system we have based on what the proposed system is. And then all the efficiencies, the capacity, you always want to double check that the capacity of your baseline system isn't grossly higher than what's in your proposed. A lot of times we have redundancy in the proposed. That's why this one's so high. But you can really see what the efficiencies are in the baseline as compared to the proposed, what system we selected in the baseline, and then the capacity.
Okay. Huh. Yeah, gosh, service water heating. That's the same as proposed.
Yeah.
So is that 1.5 gallon per minute for are these going to be fixed flow rates for your water fixtures on all projects, or I'm obviously if you were installing more efficient fixtures or with lower flow rates, you would change that?
Yeah. So this is the water sense fixtures are required in Colorado.
Okay.
So we have water sense as our baseline here, and then they only met the water sense requirements in the proposed.
Okay.
There's also a note in the section C407 that says your capacity of your baseline system has to be the same as the proposed. And so there's a question there about, can we actually take credit for reduced water fixtures in the proposed? So we always model the capacity of the water heaters the same in the baseline and proposed, but we had previously been taking credit for less or more efficient water fixtures, but Denver recently came out and said that no, that same capacity between the baseline and proposed is also alluding to the water fixtures themselves. So we're no longer taking credit in Denver for reduced flow showers or labs.
Okay, that makes sense. And actually I had 3 more come in while we were talking. One is talking about ASHRAE 90.1 on a finish out if the building was not designed for ASHRAE, and that's not. It's one or the other. It's always you pick it and you stick with it. Mechanical, lighting, building thermal envelope, everything. It's either IECC or 90.1. So the finish out would have to be, if the building shell and mechanicals and lighting and all that were 90.1, then the finish out would have to be as well, correct?
Absolutely.
Yeah. And then a couple more. Now this one's going to be all over the board, but I'd be curious to get your thoughts. What are the differences in design cost, if any, between performance versus prescriptive paths?
That's a great question. So normally what we see is a building wants to go through the performance method because they want to increase their glazing. So right away, right off the bat, that building costs more than a prescriptive building. Glass is just so expensive. Or we have now in Denver, we have a green buildings ordinance. So we require additional green buildings measures, I guess is the best way to describe it. And one of those options is energy efficiency. And so we've actually found that increasing your energy efficiency by a small percentage is one of the cheaper options to meet that path. It really depends on who the occupants of the building are and why that building is being designed the way that it is. For a rec center, for example, or a school, we don't see them increasing their glazing, their window to wall ratio, I guess I should say, above what's prescribed. But they often say that they don't want to comply with the prescriptive wall assembly. They want to only go look at continuous insulation. And that's actually a cheaper wall assembly, but it's easier to show compliance with the code when they via the performance method if they want to reduce their insulation levels or just go with continuous insulation. So there's a bunch of different ways that you can look at it, and it really depends on why they're designing the building the way that they are.
Right, yeah. My answer would have been, you can't answer that question because commercial building types are so various that it could be performance on 5 buildings in a row and then prescriptive on 5 buildings in a row. You just really can't. It's so hard to tell. Okay, last question. And oh my goodness, we are just almost right at an hour. So this is finishing up right on time. What information is provided to the inspectors to inform them of the performance changes inherited in the design? Not positive what that's asking. What information is provided to the inspectors to inform them of the performance changes inherited in the design? Do you understand that one?
Yep, I do. It's a question a lot within the city. So your inspectors go on site and they are saying, hey, this assembly, this window or this insulation assembly isn't what's prescribed in the code. What are you doing?
Gotcha.
So this is the letter that we suggest you guys provide so that they can say, all right, in the proposed design, it's on sheet GA 501. They have R11 bat with 2 inches of XPS. On the same,
Gotcha.
they have R10 rigid, and that's what they're looking for.
Perfect. Yeah, having those submittals and having all that paperwork on site will help your inspector a ton. Now, whether or not the GC can find that and get it to the inspector when he comes to the job, that's a whole nother issue. That was fantastic. Thank you so much. That really, I mean, now don't get me wrong. I'm still thoroughly confused. Need to learn a whole lot more, but really great information. Good questions from the audience. Thanks everyone for attending this morning. Would you like any parting words of wisdom or anything else before we end it today?
If you guys have any other questions, here's my email. This is my desk phone number, so I am not there, but I will get a voicemail if you leave me one. And feel free to reach out if you have any questions. I'm happy to answer them.
Awesome. Thank you so much, Anna, and thanks so much for everyone for attending this morning. I will be sending out next week's webinar invite probably on Friday. I haven't decided what I'm going to do yet. I'll probably do it myself next week, So we'll talk to you soon. Thanks again, everyone. And thank you. A special thanks to Anna. Y'all have a great day.
Thanks, everybody. Stay healthy.
Yes.
Bye.